Hello and welcome to pdfsupply.com. Today I'm going to be testing or showing you guys how to test an RX3i mixed analog card. This is an IC694ALG442. It's mixed because it has 4 input channels which measure voltage 0 to 10 volts or current in milliamps, 4 to 20 milliamps or 0 to 20 milliamps or 4 to 20 plus milliamps. And there's 2 outputs that put out 0 to 10 volts or 0 to 20 milliamps current, okay, depending on what you guys select. I currently have this open so that you guys can better see the terminals and the jumpers that I have, which I'll describe in a moment. This is what the front of the unit would normally look like if this cover was on. And we'll be also showing you guys a wiring diagram for this device, okay? One thing I wanted to point out before you put the terminal strip into the unit itself is that it should have a 24 volt power supply, 24 volt DC. You can see my positive lead on terminal 1 and my negative lead on terminal 19. And you guys are going to need this for your current readings, input current readings. Also, I have jumpers on 2 and 4, or 2 to 4, 3 to 5, 8 to 10, and 11 to 13. Those are also used with current, okay? So I have the device attached to an IC695CHS007 7-slot rack. It's being powered by an IC695 PSA040 power supply. And the processor I'm using for this test is an IC695 CPU320, okay? And I'm attached to it using an HE693 CBL232. This is a 9-pin cable, and the adapter I'm using to achieve the 15-pin COM port 2 is an HE693 SNP232 adapter, okay? So, as you can see, I have the power supply powered up. All the units are powered up. I have an OK light blinking on the module in question here. This is the IC694ALG442 again. So if you don't have a green light, or if it's a red light, or if you don't have any light at all, then immediately that means you have if you're doing this as a troubleshooting to see if there's a problem with this, then without a light, then the module's not going to work and you won't be able to follow this test. That would mean that it needs repair or replacement, okay? But if your system looks like this upon power up, then you guys will be able to follow this test. Now, most of this test is going to be in the software. I'm using Proficy Machine Edition. I've chosen an RX3i CPU320 test file, which is blank, there's no program, and I use it to test different devices. So the first thing that you want to do under Navigator is expand your rack 0, your main rack, and you want to make sure that you have everything that you see physically in front of you on the video in the actual rack itself. You may be using a 12-slot rack or 17-slot. That's all fine. But for example, I have rack IC695 CHS007. Using slots 0 and 1, I have the IC695 PSA040 power supply. And using slots 2 and 3 is the IC695 CPU320. Okay, so both of the large devices are using 2 slots, and that leaves us with the next available slot, slot 4. You can right click on that or double click, select add module, and it would be analog mixed IC694ALG442. Alright, now unlike with some of the other analog input and output where you have to select as many channels as you want to be able to use or read with, this is preset at 4 inputs and 2 outputs. A couple things that you want to look at under your settings and parameters is where your address is, where you're going to be reading the values. If it's a new file like I have, it should start as %analog input AI 00001, and as far as the outputs are concerned, it's %AQ or analog output 00001. Alright, so those reference addresses are important for when we want to do our test where we need to look. Now, if you open up the output channel data, this is the 0 to 10 volts is what it's going to default to. But you can see the choice list here, which is 0 to 10 volts negative, 10 to positive 10 volts, or 4 to 20 milliamps, 0 to 20 milliamps. These are all the choices. I usually start with just the default 0 to 10 volts. And the input channel, same thing, 0 to 10 volts. All right? So first thing we're going to do is connect up to the processor. I'm using this lightning bolt icon. All right, now notice the status bar as we go through this. It's in monitor mode, stop disabled referring to the inputs and outputs. Configuration and logic are both not equal because the processor was doing a different task before this. So we're going to hit the handprint icon, this green handprint. It's going to put us into programmer mode down below again. And before we download to it, I'm going to go to Target, Online Commands, Clear. Now, as I mentioned before, it says that it's not equal. Configuration and logic are not equal. That means the processor was doing something else. So what we want to do is clear the bottom two selections, controller fault table and I/O fault table. Select OK. We don't need to clear all the memory or anything like that. This is just going to keep us from getting hung up when we go to download. All right. As we go through the download process, the first thing it's going to ask us in a second here is, what do we want to download to the controller? All right. Now that'll be the top two selections, which is hardware configuration and motion and logic. We don't need to write any initial force values or controller supplement files, nothing to permanent flash memory. Again, this is just a simple test. We're going to be probing the inputs and probing the outputs to see what type of power they're delivering, if they're accurate or not. And I'm also going to tell you guys a little bit about range and resolution and how to test that. Okay. Another thing to keep in mind during this test is typically what we see, not always, but a lot of times when the analog cards fail, especially when it comes to milliamps, it fails at full value. What that means is if you go to probe the inputs with a milliamp generator, which I have here, it'll immediately tell you you have 32,676 engineering units, which is the full 32K value. And then when you go up and down those values to see that it has range and resolution, to give it more milliamps and less milliamps, it won't change. So it's important that you guys check your range and resolution. I'm going to touch on that more in a moment. So we're in run mode. One thing to keep in mind with your processors I wanted to mention, if I open up this door here, make sure that you're in the far right position with this switch, which is your run I/O enabled. If you're in the middle, it's going to disable your outputs, and if you're to the far left, it's going to remain in stop mode or without the run on. Okay, so make sure that's on. Okay, next, we're going to go to, in the navigator bar here, default tables, expand on that, and now we have the different tables where we have our reference address. We're going to start with input. All right, you can double click or right click and select open. And our inputs are, as I mentioned before, analog input 00001 through 4. That's all the way over here, okay? So start with 1. And what I have here is I like to be able to test the middle of the range, or a third of the way through the range anyway. This is just a 3-volt battery. It's a memory battery. I have a couple leads coming off of it. And I'm going to probe my inputs. Okay? Starting with channel 1, which is terminals 4 and 6. To get a reading. Okay. Now, one thing that you may have noticed I forgot to mention, I did mention that you need a power supply. When you turn the power supply on, this green light should come on, user supply. Okay, that's another potential problem, is if there's an issue with the card being able to retain that 24 volts that's coming in, then you wouldn't be able to follow this test, and it would also need repair or replacement. So make sure when you turn your 24 volt power supply on, as I just did, you get this green light. All right, so I'm going to probe again, 4 and 6, 4 being positive, 6 being negative. Now I have engineering units of about 6820, 6812. I'm going to go to channel 2. Now what I'm looking for is the same exact range, or very, very close. Same engineering units, okay? If one of the channels is reading way off and all the settings are the same for all 4 channels, then there's obviously a problem with that particular channel. And as you guys can see, all my channels are reading the same right now. Okay, so I'm satisfied with the inputs. Next thing I'm going to do, and you guys are going to need some sort of a voltage meter for this. I'm using a multimeter. I'll show you guys what I'm using here for a second. This is a Fanuc multimeter. I'm going to be checking my values in voltage. And I'm going to open my analog output table so that we can give it some voltage. I'm going to show you how to do that here. Analog output 00001. And I'm going to give it the full 32,000 engineering units. Okay, so it's 0 to 10 volts output when it's selected for voltage. And that means when I probe my channels, my output channels, I should get a full 10 volts at 32,000 units, okay? So what I'm going to do is I'm going to put my negative on 18. Okay, you can see here my negative probe on 18. My positive probe for channel 1 output on 14. And I should get a value of 10 volts. Okay, perfectly 10 volts. Same thing with channel 2. 10 volts. Now here's what I was talking about with range and resolution. Here's what you want to do to further test this. I'm going to drop that 32,000 in half to 16,000 on both channels. And what that means is I'm expecting to see half of the voltage. In other words, it should be 5 volts or very, very close to it. Okay, and we have 5 volts. Channel 2. The probes on 18 and 16, negative on 18, positive on 16, 5 volts. And you can keep going down. You can go to 8,000 and you should get 2.5 volts. 4,000 you should get 1.25 volts, and so on. If you want to, go through that much trouble to do it. But this is a working card. I know it's a good card, and it's a good example to show you guys how to check range and resolution, which we will be doing next on the input milliamp side. All right, now, so we're satisfied that the voltage works. We're not sure if the milliamp works. We're going to stop this processor, shut off the outputs. We're going to go into our settings with our ALG442 analog output data, and I'm going to select 4 to 20 milliamp. I'm going to go to my input data and do the exact same thing, 4 to 20 milliamps. The drop down allows us to edit it, select 4 to 20 milli. You guys could do 0 to 20 or 4 to 20 milliamp plus. It doesn't really matter, just as long as you're selecting some sort of current, a value that's measured in milliamps. It doesn't matter what it is. Now I'm going to go back to target, and we're going to go to clear again. Make sure you do this. And we're going to clear the controller and I/O fault table because we're asking it to do something slightly different than it did before, and it knows the difference. So select OK, and this way we won't get hung up on the download. And then we'll select download and run. You can see my arrow up here with the download information and run button. Same thing when it asks us exactly what is it that we want to download to the processor. It's just going to be configuration and motion and logic. I'll show you guys that as soon as that screen pops up. Hardware configuration, motion, and logic. I'm going to select OK. Now, the other test device that I have here now, besides having a separate 24 volt power supply and this Fanuc instrument multimeter, is a 4 to 20 milliamp output generator, right? I have a dial on my generator. You guys aren't able to see this, but I have an on-off switch and a dial. The dial allows me to go all the way to 20 milliamps and perhaps just a little above 20 milliamps, and all the way down to 4 milliamps. So as I probe each channel, I can kind of go dial it up and down, and that way I can see on the Proficy Machine Edition software, I can see the range and resolution of this card. Now, I'm going to be able to demonstrate that in just a minute when this is done downloading. And it's very important that you guys do that. I can't stress that enough. Because if you get an immediate reading of 32,000, it doesn't necessarily mean that the capability of the range and resolution of this card is working. Alright, so now we're on the analog input. I'm going to start with channel 1. Again, for your reference, that's terminals 4 and 6. Negative being on 6, positive being on 4. Here's my probes. Okay. And again, I have these jumpered, as I mentioned before. You won't be able to get a proper reading without having the upper two terminals jumpered. 2 and 4, 3 and 5, 8 and 10, and I believe 9 and 11. Okay. So, pay attention to Proficy Machine Edition, my analog input 00001. Now what I'm going to do is I'm going to dial down the milliamps, and you can see it's quickly dropping to engineering units that are lower than 20,000. It's going to continue to go down, and maybe I'll leave it right there. Okay, now I'm going to go to the next channel, and it should give me the same reading that we left off on. Okay, 12,191 if I can keep these in place, kind of like using chopsticks. So now I'm going to dial back up. And I want to get that same value, whatever it was, 31,989, 889, 899. Okay, that's perfect. So those two channels are reading exactly the same, and they have range and resolution. Cannot stress that enough. Okay. Terminal 4, or channel 3 rather. I'm going to leave it at the low value. Probe the next channel, which is channel 4, and now watch the value go up all the way to 31,879. That's perfect now. So we know that this is working properly. Again, if you guys touch your probes to any of the channels, they immediately go to 32,767, or you don't get any value at all, then there's definitely a problem with the card, especially if the 24-volt power supply is working. And the last thing, of course, we got to test our outputs, milliamp. And I've already given you guys a description on what to look for range and resolution. So we're just going to go with full value here, 32,000. And I'm going to show you where to attach your probes to get these values and what it should look like. Now, I need to set my multimeter to measure in milliamps, DC. Okay? Top right hand corner you can see DC, and I'm set for milliamps. Alright? I want to touch my negative probe to the negative lead on the power supply, which is 19. Output 1 for milliamp. Now I'm on the left hand side of the terminal as compared to the voltage. Okay, the top lead, my positive lead, should be touching terminal 15, output 1. I have 21 milliamps exactly. Okay, and same thing with the lead below that, 21 milliamps exactly. And just for the sake of demonstration, I'm going to take my two channels and I'm going to drop them to 16. Okay, I got a little lost there. $16,000. Okay, there we go. And we're going to see a difference now. Channel 1 is reading only 13 milliamps. And we should get the same with channel 2. 13 milliamps. Oh, and of course, if we zero out the values, it's still going to give us a value because we're set for 4 to 20 milliamps, so there will be a value. But, you know, it's reading 5. And that's what it should look like. Now, same thing goes for this. If you put in a value of anything less than 32,000, you should have a value that's lower than 20 milliamps. If you're still at 20 milliamps, you have a failed card, you have a failed output. Okay? So it's a kind of a complicated device. It does a lot of functions, being that it measures in voltage and current, milliamps. It has outputs and inputs. So the card's doing actually a lot of work, and it has a power supply that's going into it. And if you follow this testing, you feel that there's a problem with the card, that this is something that we normally repair here at PDF Supply. We have exchange programs, new and remanufactured products, and same-day shipping. So if that's something you guys need or interests you, please see us at pdfsupply.com. Thank you.